Thanks a lot. So without further ado, please let me introduce myself. I'm Mihai Cosma, a product manager with Telenav Europe, also a member of the PDG within the NDS consortium for the last year or so. My topic today is an application of the NDS Classic, which is map streaming. So without further ado, I'll dive right into it. So I'll start with a trending topic nowadays, which are connected cars. So connected cars, while a trend a few years ago, are becoming the norm now. Even for us as Telenav, about 16 million cars which are using our systems are connected cars. But this connectivity, while helping a lot by bringing a lot of benefits for our users, also is coming with some dilemma. And with the addition of touch-based interfaces in the car, it is basically only natural for the user to expect the car to behave more and more like a mobile device. So this is like one question that I like to address, like the audience. Is the car just another mobile device for the user? And in navigation in particular, user expects fresh data all the time and its immediate availability, so it can have delightful user experiences, similar to ones that they experience on their mobile devices. And of course, they expect this experience to be even more like enhanced by the systems that are already in the car and like sensors and various subsystems. But overall, they expect the minimum to behave at least like a mobile navigation application. And I kind of, empathize with these users. Like, it looks like a tablet, it feels like a tablet, it is a connected device, so why isn't it behaving like my tablet or my phone? And and this is, I think, like a big dilemma that we as an industry have to solve. It's like why our industry repeatedly failed our users based on like various market reports and so on, and NPS scores, why they have failed them in delivering this kind of experience. And I will share with you a personal story of mine. So before COVID, because now I'm working from home, I used to commute daily to my office, mostly the same routes. So as a product manager, I tested a lot of both embedded and mobile navigation systems on my commute. It allows me to differentiate and see how they behave. And so one day, the local authorities added this a traffic sign that says hey, no turn restriction to the left, right? And I failed to see it, and the lane markings weren't updated, but the navigation application knew. So I was wondering why do I get these routes? This is wrong. But actually the application was right because it had up-to-date map data at that time available. And then 3-4 days later, the authorities also updated the lane markings. And so basically the application was saving me from maybe an accident or something. So it's a proactive approach. And this was available due to this fresh map data available. So in my opinion, delightful user experiences on this in-car require much more fresh data than what was traditionally available in cars, and also an increased volume of information overall to be readily available in cars. But of course, and now here's the issue, is that this comes with a lot of costs and limitations. So there are costs in terms of bandwidth that's used. There are limitations on how much onboard storage you can have, but also it is not helping that the ever increase of available data that we could use to leverage to improve our user experiences. So I'm just going to give you this example. I read just the other day that a popular company launched their new version of their flight simulator. And how is this connected to our industry? Let me explain. So basically, they have this model of the world that they pulled from real maps, just to give like a lot of realism to their game. And the total size for it is 2.5 petabytes. So that's absolutely huge. But that can give us a hint of what will it be for us as navigation providers in the future to have the greatest experiences for the users in the cars. So one way to achieve, or the way to achieve these kind of experiences with such big data is usually streaming, right? If you look at, like, even if in the apps that you're using daily on your phones, whether it's like news apps or social media apps or, you know, videos, media, games, and even, or more especially navigation, all of them are powered by streaming on mobile devices. So maybe we could say that most of our mobile device experiences today are powered by streaming technology. And therefore, most of our users are familiar with these experiences, even if they don't know what streaming is exactly. Subconsciously, they acknowledge that these experiences, right? And that's where they see the difference between their devices and the cars they are buying. So let's remember, like, really quickly, because I know like everybody here is familiar with with streaming, what streaming is. So streaming is basically a method of transmitting or receiving data over a computer network as a steady, continuous flow, allowing consumption to start while the rest of the data is still being received. So what are the elements of a streaming system? First, you have a consumer that needs data on demand, but doesn't really want to store it, just consume it. And the data needs to be fresh. Then you have the fresh data, which is stored somewhere on the cloud. And then you have a network, an infrastructure through which you stream the data from the cloud to the consumer. And then there's one more element. In order to prevent unpleasant user experiences, because the data flow might be interrupted, you have a limited capacity buffer near the consumer. But of course, everything that exceeds this capacity is lost downstream. So speaking of delightful user experiences and connected cars, right? Before I introduce you to our streaming solution, let me tell you a bit about Telenav, our company. So the first of all, any Telenav solution always starts from the ultimate customer experience and satisfaction. And it is our singular goal to support OEMs in their strategy to build lasting digital brands that strengthen their customers' loyalty. In terms of competencies, Telenav is operating on the market since over 20 years ago, building software and connected digital services, mainly for the automotive industry. We have a proven track record in delivering world-class navigation and location-based services. Our cloud-first heritage gives us tremendous experience in integrating best-of-breed cloud services and content to give us users always up-to-date and unique experiences. And of course, we can deliver seamless UX across all infotainment applications, irrespective of whether an end user is engaging in voice, visual, touch interactions, and so on. Also, it is important to mention that Telenav is a truly global company, which enables us to understand regional differences and complexities and always deliver services that are customized to meet the regional needs of our drivers. And as I was saying before, we count today around 25 million units deployed, of which more than 16 million of them are connected ones. So this is just a bit of background. So now I'm finally exposing you to our streaming solution. So our streaming solution focuses on static maps. So basically it's an NDS classic, focusing on streaming your bread and butter maps. It works on NDS 254, which is the latest version. It is part of Telenav's full navigation stack, but it was built as an independent module. So what does that mean? It's that it's adaptable. It can be adapted to existing navigation applications, and it will be easy. It is easy to port to NDS Live when it will be out. I mean, completely. I know a part of it already started. It is also, it works on NDS map as long as it subscribes to the standard. It is a flexible solution, meaning it allows for detailing balancing of delightful user experiences on one side, and then OEM's costs on the other side. So it does this by putting the application in control of what is streamed. And also it is powered by a very fast and accurate online routing service and a comprehensive online search engine. In terms of benefits, it has benefits for everybody. So on the user side, it enables user experiences by having most up-to-date map data, helping in areas like routing, e-horizon, map display, and so on. And also helps with lowering costs for OEMs by enabling low onboard storage requirements, which actually can also help with having a larger map area installed, because you don't have it to download it all at once. And also it optimizes bandwidth usage, and it makes data intensive applications, like for example, some autonomous driving use cases possible. Now, we at Telenav are kind of pioneers in terms of streaming. We already have a solution that's on the road that uses our streaming technology, but that one is based on our proprietary map format. So when we designed these systems, we have came with some concepts that I would like to introduce to you now before moving forward. One of them is the home area. So the home area is an area of the map that's most used by the driver. It's flexible, it's automatically determined by the application, and of course, always kept up to date. Another area is like the destination area, which is streamed area around a destination of a route, of course, outside of the home area. And then you have a corridor, which this might be very familiar to you. It's quite a common term. It's the long area around the route that connects the origin and the destination. So when we started to implement this solution or to move these concepts on NDS, we had some challenges to overcome because inherent to the map format. So of course, NDS Classic, as you already know, was designed more for onboard and hybrid navigation, and that means that the full map is installed on board, and the navigation experience is augmented by certain online services, for example, routing and search and traffic and so on. And the design of NDS is like they also specify, or we actually also specified how the data is persisted on storage, and that means that is for data consistency reasons. But of course, this is not really friendly to streaming, because streaming requires small streamable chunks that are loosely coupled to one another. So the best way that we found to implement our concepts was for home area to be composed of one or more full update regions, actually. And these can also be provided and streamed by our streaming system. This is a bit of a sacrifice in flexibility versus our proprietary map format, but it is best for ensuring the best user experiences. And then everything outside home area is streamed at tile level, and that is cached locally. Of course, we enable various optimization mechanisms for bandwidth usage, and we can actually even employ tile level delta updates with support from the map compilation provider, which actually enables a dramatically reduced bandwidth usage. Then we have a powerful routing engine online that calculates routes, and they can be rendered and used even if you don't have any map data under them. But if you are, for example, left in the dark, you don't have a connection anymore, then we have an onboard routing system that successfully routes within the data already downloaded on board. For search, as I previously explained, we have this comprehensive online search engine. For the onboard, we have several solutions available, but each one of them comes with some compromises. And of course, we hope and know that NDS Live will help us with this. So now I would like to show you two videos that I've recorded. I didn't want to do a live presentation because usually through Zoom, the frame rate is very low, even for videos sometimes. So, but what I want to do is stop sharing for a second and share again with sound, because I forgot to enable sound, if that's okay with you. Is that okay?
Yes, sure.
Okay. So I stop share, and when I choose, I share computer sound. Okay, should be back any minute. Can you see my slides?
Yes, we do.
Okay, okay, thanks. So first of all, I would like to show you a demo of our routing service, because like I've said a lot of good words about it. Our routing service, it works online, and I'm gonna play it now. Hopefully you can see on your side as well. Okay. Does it work?
Yeah, it's zooming in.
Yes.
Yeah, this zooming in shouldn't happen. Actually. Okay, this doesn't really look good. I can play the videos like in a player, not in PowerPoint. Do you think should I do that?
You tried.
All right. Let's see. If not, there's a backup on your side, right?
I have a back on my side, yeah.
Just a second. Okay. Oh, come on. All right. Now I managed to put it. No, I wonder, can you see my screen better now?
Yes, yes.
Right, so it works. Okay, so what you are seeing here is basically routes calculated online. And the server is in Cluj, the client is in Germany. That's how we recorded it. Most of the delays that you see are basically network delays, going through VPNs and so on. Any route is calculated in less than 500 milliseconds across Europe. And it's like already delivered on the base level, like the level 13, ready to be navigated on. Here's like an attempt to drag the destination route, and the route is calculated. Again, all the delays are coming from the network. And then we'll attempt some longer routes. for example, from Eastern Turkey. And up to Edinburgh, which is kind of what we thought of a long route. All right. And then the second video is actually about how the router integrates with the streaming system. And it will
Hello,
be narrated
I am
by
Alex
a colleague
Priguana
of
from
mine.
the Telenav NDS engineering team, and my goal for the
Can you
next
hear
minutes
any
is to
sound?
present to you how the routing functionality interacts with our new streaming feature. I start on an
Right.
empty map. As I enable the internet connection, tiles are downloaded on demand and immediately rendered on the screen.
Okay, so
I am free to switch the streaming function off, in which case the engine will just draw whatever tiles it has already downloaded. Enabling streaming on again will resume tile download. I am free to select a destination to a region of the map where I have no data, for example Hamburg. The route is computed in the cloud and ready for navigation. Only the first few kilometers have map data underneath them, the rest of the route is just drawn over the empty map. Let me demonstrate that quickly by panning along the route with internet turned off. The moment I enable my internet connection back again, the app will download the map tiles as I progress with my navigation and recalculate maneuvers accordingly. If, however, I do not wish to turn streaming on again, or want to be independent of the internet connection on the way, I have the option of choosing tile prefetch. This feature will pre-download all the map tiles along the route so that I can permanently go offline while driving. The route is again available right away. I can start navigating while the rest of the corridor is being streamed. I will be notified once tile prefetching is complete. I can now switch off all my online functions. Let's have a look at the route. The tiles with the highest level of detail are available along the corridor, so that my navigation experience is the one I expect. Furthermore, if I choose to change my destination while still offline, I can do so, but only inside the downloaded corridor. This route was calculated fully on board, using only the tiles I downloaded with prefetch so far. That concludes this routing with streaming demonstration. Thank you for your attention.
okay, so that was it from my side. Thank you for attending. Hope you like it. If the quality was not good enough, maybe I mean you have the videos there. Maybe you can play them back. I don't know how well it went. So honestly,
What wasn't bad?
okay. Zoom is playing like I mean here it's running 60 frames a second, but there might not be as good.
Not free with Zoom. Yeah, still I think we could get some of the concepts. So thanks a lot, Mihai, and videos are available.
There's one question.
Yeah, one question. Can you?
Yes. So the question is, I think it referred to the demo variant. Does this calculate the alternative route also? If so, how much is the response time for calculating the alternative routes?
So you mean if you have a route, like how fast do you calculate the other alternative routes? Is that the question?
Yes, right.
It's the same speed, basically. So we try to have this under 500 milliseconds as a constant. So that's our goal and limit. Yes.